We're going to look at lesson 2.3, which is on solving multi-step equations. We're going to look at page 94. Before we do that, I'm going to give some steps for solving equations. Some of these steps we might not need all of these just yet for this section, but some of these we'll be using in the next lesson, so we'll just go ahead and get them all right now. And then if you don't need some of the stuff yet, then you don't have to worry about it. So for solving these equations, the first thing is we're going to simplify each side of the equation. So distribute and combine like terms on the same side of the equal sign. That's in parentheses, so that's not same side of the smiley face. The second step is we're going to get the variable on one side of the equation. Then we're going to get the constant on the other side of the equation. And then we're going to multiply or divide. Okay, so once again, these are the general steps that we'll follow. There could be a possibility of some equations where we're not exactly following these steps. For example, in the last lesson, we did the problems with the fraction, where the variable was in a fraction with another term. So there's cases where we may not do these, but most of the time, these will be the steps we'll be following. So keeping those steps in mind, if we look at this on page 94, if you look at problem 1, they're wanting us to find the solution for this equation. So one thing a little bit different on this problem than what we had in the previous lessons, you'll notice, is that there are two variable terms. These variable terms happen to be on the same side of the equation. So like terms on the same side of the equation can be combined. We can combine like terms if they're on the same side. Okay. The book rearranged these with the commutative property. If you were doing this problem and you just want to circle those like terms and then combine them, that's fine. Just make sure you remember the sign to the left goes with it. So 5m plus 2m would be 7m. At that point, we actually have a two-step equation. So you could say they're subtracting 23. We could add 23 on both sides to get that to cancel. And then they're multiplying by 7, so we could divide by 7. So once again, the book has a little bit of extra steps here we don't have to do. It's not really extra steps. They're just rewriting the problem multiple times. And then just like before, when you're solving an equation, once you get your answer, you can substitute that back in the original problem and check your answer. So that's what they did at the bottom. The only difference here, since we had two variables in the original problem, two m terms, we had two places we had to substitute the 4 in order to work that out. So anyway, they worked it out. 5 equals 5, so we know we've got the right answer. Okay, so this one, going back to those steps, basically for that one, we're not doing all these things, but we did combine like terms on the same side of the equation. The variable was already on one side of the equation. We got the constant on the other side, and we multiplied or divided. So, there's 3 things there out of maybe a possible 5 that we did on that problem. So if we look at the got it 1, we've got some similar problems here we're going to look at. So on part A, first thing, if you'll notice, once again, we've got like terms on the left side here we can combine. One thing to watch for is that's a minus 6m or negative 6m. So 11m minus 6m would be 5m. Okay, you can add the opposite there if you want, if that helps you, but make sure you don't lose that sign. Now we're really at a two-step equation like we were previous section. They're subtracting 8, we can add 8 on both sides, keeps our equation balanced. And then they're multiplying, so we divide by 5. So m equals 6. And once again, if you have time, substitute that back in to that original problem, work it out. You should get 22 equals 22. Part B. First thing on this problem, once again, is that we have like terms on the same side of the equal sign. So negative 2y plus 5y would be 3y. Then they are adding 5, we can subtract 5. So 3y equals 9. Then they're multiplying by 3, we can divide by 3. So y equals 3 would be our solution. Problem 2, we've got a story problem, word problem, whatever you want to call it. Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. Bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. The total is $67. What is the cost of 1 shirt? Okay, so one thing you can do if you're doing a problem like this, especially if you're doing this on a test, if you have colored pencils or something, obviously you don't want to do this in your textbook, but on a test or on a just piece of paper, you could color code this. So I just used the black for bumper stickers and blue for the shirts, and then you can kind of see overall here what's happening a little bit easier maybe. So the niece is getting a shirt and 4 stickers. The nephew is getting 2 shirts, and the total is $67. One thing you could do, you could just kind of combine that in your mind before you ever set up the equation if you want. You could say, well, she's getting 1 and he's getting 2 shirts, so that's 3 shirts altogether. Does that make sense? So however you do that, eventually this would be the equation you should come up with, whether you started at that point or not. The parentheses wouldn't have to be there, by the way. That's just kind of separating the niece's things from the nephew's. Anyway, they subtracted 4 divided by 3, and they got $21. So look at the got it 2 at the bottom of the page. We got a similar story. Noah and Kate are shopping for new guitar strings. Noah buys 2 packs of strings. Kate buys 2 packs of strings and a music book. The book costs $16 and total cost is $72. So how much is 1 pack of strings? So a problem like this would probably be good to define a variable first. So for example, we could say let P represent the cost of a pack of guitar strings in dollars. I just did P for pack. You could have done G for guitar, I guess. String you could do, but if you do S for string, you probably want to make that a cursive S so it doesn't look like a 5. So that's why I didn't choose S as my variable. So if Noah bought 2 packs, that would be 2 times P. Kate bought 2 packs, it would be 2 times P, plus the music book, which was $16, equals $72. So once again, we've got variables on the same side, like terms that we can combine. So next step, they're adding 16, we can subtract 16. They're multiplying, so we can divide by 4. And when you divide that out, it would be $14. So one pack of strings costs $14. And substitute that back in the problem and make sure your answer is correct. Problem 3, we are solving something that involves distributive property. So notice on this problem we've got parentheses around something. So when you have a number right outside the parentheses and inside the parentheses they're adding or subtracting, that's our cue that we're going to be using distributive property, which was one of the steps that I mentioned at the beginning of the lesson. When you do distributive property, if you want to just take a second to write down what you're multiplying, you can do that. You can do it in your head, just be careful, especially on a problem like this. Watch the signs. Right here is what gets people sometimes, okay? You need to see that basically as a negative times negative if you're distributing that in. So when you distribute, you get negative 16x plus 8 equals 36. At that point, we've got a two-step equation. They're adding 8, we can subtract 8. And they're multiplying, so we can divide. And we get negative 7/4. So there's a switch. We've got a problem where the answer didn't come out very nicely. We didn't have a very nice solution for that one. That's how it works sometimes. So substitute it back in, and it actually will work out when you check that answer. So if we look at the Got It 3 Part A, they're wanting us to find the solution for this equation. So first thing on this problem would probably be, go ahead and use the distributive property. So 18 equals 6x minus 18. And now we've got a two-step equation. They're subtracting, so we can add 18. I mentioned it earlier. If you don't like the variable being on that right side of the equation, you can flip-flop the sides, switch them around if you want. Then they're multiplying, so we can divide by 6. So x equals 6. They asked us to check our answer. So if you put 6 back in the original equation, 2 times 6 is 12. 12 minus 6 is 6. And 3 times 6 is 18, so that works. So Part B asks, can you solve the equation in Part A by using the division property of equality instead of the distributive property? So they're saying, well, we distributed first. Could we have divided first on that problem? Would that still work? So what they're getting at here is that this 2x minus 6 that's in the parentheses is being multiplied by 3. So you could say, let's divide by 3 to get that part by itself. So 18 divided by 3 is 6. And now we've got a two-step equation. They're subtracting, so we can add 6. They're multiplying, so we can divide by 2. And we get x equals 6. So it actually works. So to answer their question, can you solve this using the division property of equality? The answer is yes. But what I want you to think about is if we go back to problem 3. So problem 3, think about the same thing and think about if you did that. So that would say, well, yeah, we could divide by negative 8 on both sides of the equation. And here's our problem. 36 divided by -8 doesn't come out evenly. So you're either going to be working with a fraction or a decimal for the rest of the problem. So that's the reason when I gave the steps earlier, that's the reason I suggest let's just go ahead and distribute if we have parentheses, okay? Also, it's less to remember, and you don't have to think about, well, does this come out evenly or does it not? If you want to look at it, you can. If you want to look at this and say, well, that would go in 4 times with 4 left over, so that'd be -4.5. And then now we're adding 1 to -4.5, which is going to end up being -3.5. And then we're taking half of that, which is going to be -1.75. So it works, but without having to deal with the fractions and decimals until the end, I think is maybe a little bit nicer to work with. So we're going to be splitting this lesson into 2 parts. So this will be the first part, just through problem 3. So we're going to look at number 5 on the lesson check on page 97. There's a 12-foot fence on one side of a rectangular garden. The gardener has 44 feet of fencing to enclose the other 3 sides. What is the length of the garden's longer dimension? So anytime with problems like this, I highly recommend drawing a picture. We've got a rectangular garden. So a 12-foot fence is on one side. The reason I'm putting the 12 there is because it's asking what's the length of the longer dimension. So I know the 12 must be the shorter dimension. And so if there's 44 feet of fencing to enclose the other 3 sides, this is like the length. So one thing to watch for on this problem, I actually missed this the first time, is the 44 feet of fencing is to enclose the other 3 sides. The other 3 sides. So you can think of it as these sides if you want. This 12-foot fence is already here. So this would be 12 over here we could think about, but it's just 3 sides we're enclosing, not 4 sides. So we've got a length, and a 12. And they add up to 44. So we can combine the L's. L plus L is 2L. They're adding, so we can subtract 12. And then they're multiplying, we can divide by 2. So L is 16, so that would be 16 feet. And we can verify we got 16, 16, and 12. Adds up to 44 feet, so we should be in good shape there. Plus the 12 feet that was already there to begin with. One more thing we're going to look at, it's not in your book, but just to make sure you guys are good with what we're doing here. And try and work that one out. So on this problem, thinking back to our steps we talked about at the beginning of the lesson, the first thing you want to do here is to distribute. Oh, by the way, going back to what the book was asking about, could you use the division property, whatever. This one, for sure, you wouldn't want to divide by 3. It's not going to come out even. Plus, you're going to be having to divide the 5 by 3. So now you're going to have fractions on both sides of your equation. So just another reason why just using those steps that I gave you at the beginning of the lesson is probably going to be a good idea. At this point, we've got some constants on the same side here. Make sure you keep the signs together. 5 minus 6 would be -1, so you could have either -1 plus 3x or 3x minus 1, just depending how you order that. And then to finish this off, they're subtracting 1, or we need to get rid of a -1. so we have to add 1, and then they're multiplying, so we need to divide. So x equals 3. So this gives you an idea, a little bit of solving multi-step equations. Have a good day.